welcome back. So, in the previous lecture we discussed about mainly the interior of earth, and we to some extent we talk about the plate tectonics, what exactly it means is the driving force where we see the movement of plates, different plates, and because of the tectonic movements we have the different landscape, and we also talked about the isostasy mainly. Now, talking in detail about the plate tectonics, we should have some idea about the background. We should have some idea and background about the geological time scale. Now, geological time scale, quickly if we look at, we discussed in one of the slide in previous lecture with we were talking about the era, period, and then we talk about the epoch. Okay. And that was the slide which I was talking with the spiral figure. And so, right now we are in Cenozoic era, and period if we take, we are in Quaternary period, and further epoch if we take, we are in Holocene. So, this is what is the time scale, but it goes back right up to like as old as you have in million years. So, from the onset of the earth's birth. So, that is the what we have, the Precambrian, and we have different eons, and then we are getting into the eras here, and then further eras what we shall all talk about is Paleozoic, Mesozoic, and Cenozoic. So, the plate tectonics mainly, it started with the thought process of this gentleman Alfred Wegener, who gave an idea about the continental drift. So, looking to the outer boundaries of different continents, he suggested that it is very similar to the jigsaw puzzle. So, in 1912, Alfred Wegener is German meteorologist, proposed that continents were all together like one piece, and he named that as Pangea, means all land. So, it was one single land, and that means that all continents which we see now were all together. Then they drifted apart and reached their present location, and this theory was been termed as continental drift. Initially, not all believed in this theory of continental drift and plate motion, but now we are sure, and it is one of the robust theory which was been proposed. So, if you look at the earth globe, then what you see is the two continents, the outer boundaries are very much similar, that is Africa and South America. So, the line which has been shown here, the red one, this is the outer boundary. So, if you fit this, and that is why it has been said as in jigsaw puzzle. So, if you fit this corner over here, then it will fit exactly into this. Okay. So, this also suggests that these two continents, that is South America and Africa, were together in past geological time, and they moved apart, and the landscape, that is an ocean which was been formed at the later stage during the drifting of these two. Still they are moving away from one another, and the crust which is this portion is the continental crust, and the portion close to this is the oceanic crust, and similarly you have on this side also. So, this were together, but now they are away from one another. So, Alfred Wegener in 1912 gave the concept of continental drift, and later on what we talk about the plate tectonics came in. So, the whole landmass was one, so one single Pangea, and all continents were together. So, even India was sitting south of the equator. So, all were together, and this what we can say, the Pangea, the landmass of comprised of all continents, was engulfed or encircled by a sea which was been termed as Tethys Sea. So, this is again an hypothesis in the theory which was been given of continental drift and the plate tectonics. So, the area north of equator was been named as Laurasia, and south of equator was termed as Gondwanaland. So, the Gondwanaland, the India was a part of the Gondwanaland, and this was the again the portion of the Gondwanaland. So, the whole area, if you look at the even including the Australia, Antarctica, India, Africa and South America, all were together, they were south of equator, and north, if you see, they have not moved much, but of course they have separated. This is one is North America and Eurasia. So, the Eurasia where we have the China and all that. Now, that was not the only criteria which was enough to fulfill or to justify that this continents, because the outer boundaries were together. So, they were together, but or the outer boundary fits or very similar to the one continent and another continent like South America and Africa, and also the North America and the Eurasia. So, these continents were together, but also what they looked at is the floras and faunas, and they identified that since this landmass was together, they experienced similar type of climate, and the faunas or were also. So, the animals which were been identified were very much similar because of this similar environment or the habitat. So, this is another example which helped in understanding that this continents were together. Another example was the rocks which were been found from this portion of different continents were very much similar. So, the glaciation in the warm areas. So, this again helped. The inset photo shows the glaciation grooves like those found in the glaciated areas, but now if you talk about India or even this region, we do not have the glaciers, but the initial time when they were together, the climate was different and this area was under glaciation. So, Australia, Antarctica, India, then you are having the Africa which was experiencing and having the South Pole, this all area, and even the South America, this whole region shows the evidence of glaciation or the movement of glaciers during warmer periods, because this type of striations or the features or the grooves you will be able to see in the glacial regions, and when the glacier moves it will result into the formation of such grooves. When we are talking about the in coming lectures the glacial landscape, you will come and you will be able to understand about the how these features are formed when the glacier moves. So, continental drift, the supercontinent Pangea began to break at about 225 to 200 million years ago, fragmented in numerous continents. This is what it shows. So, it started with, they were together at around 225 million years ago, and slowly they started drifting away from one another. And this drifting, you can see that the India moved from south of the equator and it traveled. So it traveled a huge journey, and similarly other continents also drifted apart from one another, and this is what we see the present day. So you have the Laurasia, which has been shown here, and then the fragmentation of the Gondwanaland, which has been shown here, has been present situation. What you see is this one, and still these plates are in motion. So as I was talking about that, the not only the rocks or the signature of the glacier movement were enough, and not only the boundaries which were matching, that is the jigsaw puzzle, was enough to prove that these continents were together, but along with that the occurrence and the distribution of fossils and plants, that is the flora and fauna and animals, shows a definite patterns about their remains as shown in the color bands here. So this different animals and the floras, they showed a very similar pattern in all these continents. So this also helped in proving that yes, of course, these continents experienced a similar climate once upon a time in the past, in the geological past, when they were together in the southern hemisphere. So this is the present configuration which you can see here. So you have the continental crust, which has been shown in green, and the darker portion of the reddish or the brownish are the hilly elevated portions. Like here we have in the South America, we have the mountains here along the North America, and we have the mountains here in the South Africa, and then we have the Mediterranean mountains and the Himalayas in this region, and then finally we see we have the China. So this is and in the ocean part, this is all is the mid-oceanic ridges which keeps on moving apart from one another and keep adding the crust, whereas this portion of the plate, it's subduct below the continental crust. So we'll talk in detail further of this portion. So let's see what we have more. So this shows the arrows shows the movement of the different plates with respect to one another, that is towards, it moves away like what has been shown here. So this portion, from this portion, these two plates are moving away from one another, whereas here the plate is colliding, the two plates are colliding. So one plate is moving in this direction, another opposite to that. So they are colliding with respect to one another, and then this is what has been termed as subduction zone. And then we have the location of hot spots, okay, where the plume activity is active, and this arrows which have been shown is the direction of the movement, plate movements. So we have like dozens of plates which are moving relative to one another, and as we were talking in the previous slide, that they collide, that is they subduct, that goes beneath the another plate with respect to the other, or they move away, or they slide even pass by with respect to one another. So here this plate, that is an Pacific plate, is moving in this direction, and the North American plate is moving in this direction. So what drives the plate, as we have been talking about, that the convection currents are the most important player that moves the oceanic plate and the continental plate. So the convection currents which are developed because of the the heat which is transferred not only from the interior of Earth, but also because of the decay of the radioactive minerals or the rock which are comprised of the radioactive minerals. They keep on adding the heat in the asthenosphere, and asthenosphere being partially molten, it will keep generating the convection current, very much similar to what you see the figure here, that if you are having a soap solution and if you keep heating with the burner at the below and the soap solution in the beaker, the hotter particles will come to the surface, cool down, and then goes back, and this is because of the convection currents which have been developed here. So, this is the asthenosphere is very much similar to this. So, the hot water rises, if you are having a soap solution, hot water rises on the surface, spreads and begins to cool, and then sinks back to the bottom of the pot, where it is reheated and rises again. So, similarly, if you take in terms of the crust, that is either it is oceanic crust or the continental crust, it will go back into the asthenosphere, melt, and will rises again back to the surface. So, new crust has been added and crust will be destroyed also. So, this phenomena or the process is very much similar to what has been shown as in the soap solution in a beaker. So, this you can remember that what is the reason for the movement of the plate, and this has been shown here similarly. So, we have the convection currents which are developed within the earth's surface, and which is very much similar to the convection currents which are developed, or the convection motion which has been developed in a hot water when it is heated and if it is with the soap solution. So, further with this understanding of the era, period and epoch, please have a look at this, where on this side it shows the time and the movement of the plates, and you will be able to see that as the plates are moving away from one another, in between you see some horizontal lines which are coming up. Those are the signatures of the mid oceanic ridges. So, if I just switch it back, then you see that how the continents are going back into their original location. So, and on the left hand side you see the time scale which reduces. So, 150 million years, then 160, and then finally if you go back up to 200 or so. Okay. So, they were together and then they started moving. So, I am just playing it again slowly, and you can understand that how the different continents have moved away from one another, and the India has finally reached, that is in purple, and collided with the Eurasia. So, this is what we see is the present configuration of with respect to the plates, that is with respect to one plate and with another one. So, we are having and these arrows which have been shown here are the arrows of the direction of the movement of the plates. So, some places the plates are moving in opposite direction, and some places they are sliding past each other, and some places they are subducting below one another. So, this is the portion, and then we have what we can term this as where they are sliding past each other are termed as transform margins, where they are moving away from one another are been termed as divergent margins, and then where there is a subduction, one plate subducting below or going below the another one, and we term this as an convergent margin or the subduction zones. So, plate motion, this helped, and this has been done based on the GPS measurements. Okay. So, all differential GPS which are been put across the continents helped in understanding that how these plates are moving and what is the velocity of different plates. So, the red arrows which you see here are the velocity arrows, and the length here which has been shown is 10 centimeter, and then or 10 centimeter per year, and the smaller one is 5 centimeter per year. So, you can judge that the Indian part is almost more than 5 centimeter. So, it is around 55 centimeter per year. The Indian plate is moving towards Eurasia and north-northeast direction. So, these are the arrows with respect to north, and the arrow length shows that how much is the movement. So, this is almost like 55 mm, but it is not same all along the front or all along the collision zone here, but it varies, but maximum if you look at is around 55 millimeter, that is 5.5 centimeter per year. And in some locations if you see, they are almost like over here, this is close to 10 centimeter, that is 100 millimeter per year. So, this plate motions were obtained from the GPS measurements, which keep on monitoring and measuring the coordinates 24/7, and since the plates are moving, so the coordinates keep changing. Now, another important point which we should remember is the occurrence and the distribution of the earthquakes and the alignment of the earthquakes along a specific belt. So, if you look at the cursor which I am moving here, the earthquakes are been seen all very much aligned along the plate boundaries. So, the red ones are the deeper earthquakes. So, it shows here that the red ones are the deeper focus earthquakes, and then we have the intermediate and the shallow. So, these are the plate boundaries where mostly we see shallow earthquakes, and shallow earthquakes are also been seen in where we are having the plate relationship between the Eurasian plate and the Indian plate. So, we have shallow earthquakes, we have shallow earthquakes, we have shallow as in deep earthquakes along the Sumatra trench, and then we have the shallow as well as deeper earthquakes over here, where we have the Nazca plate and we are having the South American plate. So, we have shallow, intermediate and deep. So, we have all type of earthquakes here, but as compared to this, because the configuration or the relation is different over here, and if you compare with the Indian plate. So, the Indian plate relationship is the collision. So, initially it subducted, but now it is the collision. So, all are shallow earthquakes, but here the Nazca plate, that is an oceanic plate, is subducting below the South American plate. Hence, what we see is the shallow earthquakes at the contact, but as the plate is going deeper towards the continental plate, it shows intermediate as well as deeper earthquakes. So, important part is that the seismicity or the earthquakes are very much aligned or follow the plate boundaries, that is the plate boundaries marked between the two plates and also the spreading centers. So, these are all spreading centers where we are having very shallow earthquakes. This is also again the spreading center between the two. And this what I was talking about when the cartoon which was been shown in the previous slide, where the continent started drifting from the southern hemisphere, and in between we saw some black lines, horizontal lines which are coming in. These are all spreading centers, which also shows the aligned occurrence of the shallow earthquakes. This is a similar figure which shows the plate boundaries and the bold lines and the distribution of volcanoes. So, again this is an important slide to remember that we have the different boundaries or the plate boundaries, where we are talking about the divergent plate boundary, transform plate boundary, convergent plate boundary, and the previous slide we are talking about the distribution of the earthquake, and in this the distribution of volcanoes. Okay. So, volcanoes are been seen where we have the subduction zones. Okay. That is one plate subducting below the another one. So, this is the most important one. So, the maximum amount number of volcanoes, if you see, are been seen along the subduction zone, that is in Sumatra, in the areas of Taiwan, Japan, and then we are having the North America and then South America, as well as in some locations what we see in the Arabian plates, we have the locations of the volcano, that is in South Africa and all that. So, I stop here and we will continue in the next lecture. Thank you so much.